Okay, so today we're going to go ahead and talk about center of mass. So center of mass is just the average position of all the mass making up an object. And I think of it as like kind of like essentially the balance point of an object. So let's say we have like an object kind of like in the shape of like a teardrop. So where would the center of mass be of the object? So again, that's the average position. So that's going to be near kind of the more massive side. So somewhere along here would be the center of mass. And we'll practice it for various objects. Today, we're just going to go ahead and talk about center of mass for point objects, where again we have like a little point in space. Yeah, some point in space, but it's not like a massive object like this teardrop that I just did. So the formula we're going to go ahead and use, and then we'll do two examples problems, is going to be x center of mass is going to be the sum from, let's say, 1 point all the way to n points. That'll be just mi xi over m total. So again, that's going to be m1 x1 plus m2 x2 plus dot 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 until however many particles you have. And again, with these point particles, we're saying like they are at some location of space, like they themselves don't have any big like kind of heavy weight or like, sorry, they have weight, but they do not, but they essentially don't have like a size that they're making up. So first thing we'll do when we'll go ahead and solve center mass problems is go ahead and draw our coordinate system. And so we will draw, I think of it as like I have a little ruler underneath. So I'm going to say the far left-hand side is going to be x equals 0. And so let's look at this object. So, and I would too encourage you to estimate where you think the center of mass is going to be before you do it. So if I look at this, I'm like, okay, I have a 5, a 3 kilogram. I'm going to say it's probably more towards the right, just because there's more heavier particles over there. But we'll find out. So the far left, I'm going to call that x equals 0. This will be x equals 2 meters right here. And then this is, we have what, 2 plus 3, that is going to be x equals 5 meters. So it's 5 meters from the leftmost point. So now let's go ahead and use this good old equation for the center of mass. So again, we'll use m1 x1. So we have 3 particles we're dealing with, plus m2 x2 plus m3 x3 over the total mass. So m1 plus m2 plus m3. So I encourage you to think about what to plug in. You all will have a good guess, but then you can watch back in on the video. So m1, let's say, is 2 times 0 plus m2 is what? 5 times 2 plus m3 is what? 3 times 5 over the total mass, which is 2 plus 5 plus 3, which is going to be 2.5. Oh, very nifty. Cool. So the center mass ends up being right around there. So it is more towards the right, but has to be closer to the heavier one, which makes sense. And it is a coincidence that it's right in the middle of it. Different masses, different lengths will be different things. Cool. So we're going to go ahead and do one more problem together. Okay, so we're now going to go ahead and find the center mass of this system. So looking at this object, so we have a solid sphere of diameter x. So in our previous example, I said that they were essentially like point masses, so they don't have a diameter, like they're just like no radius, essentially just some little point in space. Now we have a diameter. The cool thing about center mass, I want you to think about, if you had this object of 2m right here, where would you put your finger to balance it? Well, you would balance it right in the center. So I essentially think of it as like the center of mass of this object of 2m is I think of it as like all the mass right there, just at a point at 0.5 x essentially. Let's look at the other thing. So the other thing is just some stick of mass m, which it's from the length x to 5x. So that is going to be, the middle of that is going to be right at 3x, which is where your balance point would be. So again, that's like all the mass is approximated at m, where it is 3x. So I kind of think of this as a problem just like what we did above, but all the mass is concentrated here and all the mass is concentrated there, and it's like a point mass. And again, you can simplify it because balance point of that meter stick is going to be like right in the middle if it has a length of 4x. That is the center of mass of the 4x object. The center of mass is right in the middle, which turns out to be 3x in this coordinate system. So 2x from either side. Cool. Let's go ahead and solve it using our center of mass equation. So we have just 2 objects now. So m1 x1 plus m2 x2 over total mass. And the reason, again, that I approximate all the mass at the center is because if some part of it's at 0 and some part's at x, I don't know what to plug into the equation, so I just approximate it all at that middle point. So m1 is 2m, x1 is 0.5x, plus m2 is m, x2 is what, 3x, divided by the total mass, which is going to be 2m plus m. So now we go ahead and do some fun math. So 2m times 0.5x, so that's just going to be mx, plus, this is what, 3mx over 2m plus m is just going to be 3m. So then we're left with 4mx's on the top and 3m. Oh, I love it. M cancels out, and we are left with 4/3 x. So that is right here. And I like to draw in on my picture where that is. So we have x right here. This would be 2x. So 4/3 x is going to be around here. So that's the center of mass. Which, honestly, that makes sense. If this ball, the solid sphere at the end, has a mass 2m, it's going to be a lot closer to that. I should have told you all at the beginning to guess where the center of mass is, but there you go. You can guess afterwards. Sorry about that. Cool. Well, thanks for watching.